Today we gonna see the problem in DP. The problem is maximum sum of non-adjacent elements. What does it mean? Uh, we are given an array 2149. We gonna take the subsequence of the array. We gonna take the subsequence of the array and maximize maximum of the all of the subsequences, maximum of all of the subsequences in given array. What does subsequence signifies? Subsequence signifies it may be the it may be discontinuous, maybe discontinuous. uh, it it like missing the elements in the array, like 1 2 1 missing 4 9. It's also a subsequence. But it is in the order, it is in the order. You can't you can't 4 to 9, you can't say 4 to 9 is a subsequence. Not, it's not, it is not a real subsequences. The condition for the subsequences is it may discontinuous or full elements, but in the order. It is called a subsequences. From given array 2149, we gonna take the elements, we gonna take the subsequences, and uh, sum of all the subsequences, sum of all the elements in the subsequences. So we are for instance we take 249. It is the subsequences. The sum is 15, and we are taking 19149. It is also subsequences. The sum is 14. We gonna return the uh, maximum sum of the subsequences. But the problem clearly stated as no two elements or no two elements are consecutively taken. You are not supposed to take two consecutive elements. That means if you consider in the array, if 2 is taken, you are not supposed to take the 1. You can take the 4, and you are not supposed to take the 9. If you are going to take the 1, if you are going to take the 1, you can't touch the 4, because the one's adjacent is 4. You can't take the element, and you can take the 9. This is the constraint that we have. No two elements are consecutively taken. That uh, we are going to see the how to take the subsequences in an array. In an given array, there is one technique to take the subsequences of the array. It is pick and non-pick technique. Pick and non-pick technique. Pick means pick the elements. Non-pick means doesn't take the element and uh, go to the next element from that. Uh, uh, if I write the function index, what does it represents? It represents the 0 to, in that index, in that range, what are all the subsequence that are maximum. That is maximum is This represents, if uh, f of index represents the maximum number of maximum 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 of all the subsequences that we have already within the range, that are already computed within the range. It represents, when you are when you are encountering the DP problem, you are there are three steps to tackle the problem. First step is represent represent the given problem in index, and do all the steps on that index, and return the best. First thing, represent in terms of index, do all the steps on the index, return the best. These are the way to tackle the DP problem. If you directly jump into the recursive solution, first I will initialize a function. The input parameter it is index. If what if uh, we gonna we are standing at some point of time we are standing at the 0th index. In DP problem we gonna the direction right to left, so we are standing at the last index, that is index 0. If you are standing at any point of that last index, what we are going to do, we are if index is equal to 0, we gonna take the element, because we are no other options to take skip the element, or move to the next elements, whatever. The only possible way to and to tackle the 0th position, we gonna take the last element. If the index behind the 0, if the index goes behind the 0, what it will returns 0, because no other elements behind the 0, so we return the 0. First, if you are directing into the subsequences technique, pick and non-pick technique. Pick, if you pick the element, what it be, we take the element, and we are not supposed to go to the next element, because there is no we are not supposed to go to the adjacent element, so the function would be index minus 2. Not pick condition, if you are not picking the current element, that means 0 plus, then you are going to the then the possibilities are going to the next element is possible. Yeah, it is the pick and non-pick condition. If you are taking the element, you are not supposed to go to the next adjacent element, so we are going to the index minus 2 elements. If you are not picking the element, you are allowed to go the next element, so we are doing index minus 1, and return max of, but return why we put max. The problem statement clearly states that maximum of all the subsequences, so that we put max. pick and max of pick and non-pick element. That gives the answer. It's a regression solution. So the time complexity would be exponential, nearly exponential, and the space complexity means order of n. It is represents the recursive stack space. Uh, we are going to convert recursion into memoization. Why? There are in a recursive tree there are overlapping subproblems. That means we are overdo the computing for the same element. For example, if your if the index starts at 5 and it will be if your pick if it pick the element, we are going to f of 3. If you not pick the element, we are going to f of 4. uh, Again, the three we pick the third index, we are going to f of 1. It we are not pick, we go to the index 2. Again, if we pick the element, we ended up in -1. We not pick the element, we ended up 0. We pick the element index 2, we gonna end up at index we gonna stand at 0th index. If you not pick, if you going to we are going to stand on the index 1. The overlapping subproblem means we have already computed the f of 1, f of 2. So there is another f of 1, f of 0 all is in the tree. Once we compute the result, why do we need another computations? Why do we need another computations? It increases the time complexity. It increases the time complexity. So uh, it is called overlapping subproblems. So in order to prevent the overlapping subproblems, we are ended up memoization. Memoization, what does it mean? We are going to store we are going to the store all intermediate results. It's just like a lookup table to prevent the overlapping subproblems. Uh, First, when you convert the memoization, we first initialized a dp of array n plus 1, and if we gonna check if dp of I is not equal to 1. If it means if already store the results, so we return dp of I in that array. And uh, last step is store and give the result, give or return the result, whatever it. So the pseudocode will be function f of 0 if if index equal to 0, we gonna take the element. If index is less than 0, we have to return 0, and we have to check dp array have the result. If it have, return the result. If it doesn't have, go to pick and non-pick condition. Pick condition, take the element, take the index element of the index and go to the index minus 2. Non-pick 0 plus index minus 1. Third step, what we have what we have the third step, we store and return. That means uh, dp of I return dp of I is equal to max of pick and non-pick. It is a memoization technique. What would be the time complexity? Order of n. What would be the space complexity? Uh, order of n plus order of n. The first order of n represents the recursive stack space. Second order of n represents the dp array. So that order of 2n. Next we are going to do the convert the memoization into tabulation. Tabulation, first step, ACMS initialize the dp array and represents represents in terms of the in that array the code will be in memoization we have written if index is equal to 0, return array of index. It is converted into dp of 0 is equal to array of 0th element. We are introducing a negative variable to tackle the -1 less than sub problems, less than 0 sub problems, -2, -3 as well. So that first uh, we convert the recursion into loops for index is equal to 1. Why we take 1? Because the 0th element is already filled, so we take index 1 and index less than or equal less than n index plus plus. Then we copy paste the pick and non-pick conditions. We take the element as similar as in DPN regression solution. Non-take condition, there is a slight change. If we ended up I is equal to 0, that means dp minus 2 dp minus 1 would have come. So in order to prevent this, we have a, we have put a checkpoint. Let me create this. Take condition initially array of index array of index uh, is equal to array of index. Take condition is array of index. We know if I greater than I less than 1, if I less than 1, take plus is equal to dp of I plus 2. That is a condition. If this condition is to tackle or prevent the negative indexings, has similar not take conditions. We're not going to take the element and move to the adjacent elements and store the result in dp of I max of take and non-take. What would be the time complexity? Time complexity as similar as recursion solution, memoization solution, but space complexity, it will it, it will become reduced array of n. There is no we are eliminate the regression stack space. We are only need the dp array. Next we gonna optimize this dp array space as well. So third technique is space optimization. Space optimization reduce the dp space dp array into two variables. uh, there is a dotted technique. If for instance I standing here, we need the element to compute I is I minus 1 or I minus 2. If I is standing the next element, that is also we need I minus 1 I minus 2 elements only. We no need to take the further previous elements to compute the I. That means it current element needs previous one element, previous two elements only to compute the current element. When we Go to the next element, the cur becomes to the next element, the previous one becomes the cur becomes the previous element, previous one element becomes the previous two element. There are swappings to reduce the stack space, to reduce the array space. First of all, the pseudocode will be the previous uh, 2 represents 0, because if you are going to compute this element, this previous element needed, previous two element needed, previous two, there is no element in the previous two elements, so we put it up 0, and previous element is first element array of 0. Then we loop the then we loop 1 to n, and then we copy paste the technique, dp take and non take conditions. Wherever the -1 is there, we put previous. Wherever the I minus 2, we have to put previous 2. Non take condition, we not gonna take the element, and -1, so we have to put previous 2, previous, sorry, the cur element is the max of take and non take condition. Current, and uh, as we see in the dotted technique, the current element, previous element, previous two elements are swapping. Previous two element, previous cur element becomes previous one element becomes cur element, cur element becomes previous one element, previous two becomes previous one, previous one becomes sorry, my bad, this is the code, it is the solution. We are going to talk about the time complexity of the space optimization. Time complexity is as similar as all the technique, but space complexity it's reduced n to big O of n to big O of 1. It's a complex constant time complexity, space complexity, because we have required to compute the answer just in just two variables.